Hello folks, we are coming to the last part of the exercise 2.3, and it is a part 3 for us. We are supposed to find out the range. Question number 5 asks us to find out the range, and they give us everything about the function. These are the 3 subparts that's given to us. We have to find out the range. Domain in some cases is specified, right? Now here f of x is 2 minus 3x, x belongs to R, x is greater than 0. Domain is clear, x is belonging to R and x is greater than 0. Domain is there. Now we have to find out the range. Now in order to find out the range, let's substitute some values at random and judge whether we are able to. If we are able to judge the range from there, we can do it. Otherwise, we will take some other method for solving. So first we are going to take, we'll just take values at random. You cannot take 0 because it's greater than 0. Let's take 1. Here f of 1. What is f of 1? 2 minus 3 into 1, that's 3. It's minus 1. 0.5 if you want. So what will be 0.5? 2 minus 3 into 0.5, which is 1.5. This is 1.5. 2 minus 1.5 is 0.5. Then maybe f of 0.8. 0.8 means it is 2 minus 3 into 0.8 is 2.4. So 2 minus 2.4 is minus 0.4. Oh, negative answer. Here it was positive. F of 0.3, 2 minus 3 into 0.3, which is 0.9. 2 minus 0.9 is going to be, so 2 minus 0.9. So it will come to 1.1. Then maybe, have we done, 0 is not allowed, yeah. 0.1 if you want, f of 0.1. 2 minus 3 into 0.1, it is 2 minus 0.3, so that's 1.7. So the values, see, generally what we do is when we substitute the values itself, we get an idea of the range and then we are able to predict the range. But here it's all scattered. We have got some positives, we have got some negatives, and some are not very clear about the values. So we'll adopt a slightly different approach to get the range. What we will do is, whenever we have such polynomial functions, you can reach to the function by your algebraic steps, and that will help you to get the range. For example, it is given to you that x is greater than 0. So now we know that x is greater than 0. We have to reach to 2 minus 3x by our algebra. So first thing we should be getting is minus 3x. Multiply minus 3 on both sides. So what will happen? This will become minus 3x. And please note, children, please note that whenever we multiply a negative number on both sides, then the inequality reverses. So the inequality is reversing like this. So it will become minus 3x is less than or equal to 0, because 0 into anything is 0. So you have got minus 3x less than or equal to 0. Now what will happen is you have to get 2 minus 3x. That means plus 2 has to get added on both sides. Just like equations, even in equations, we'll add 2 on both sides. So when we add 2 on both sides, 0 plus 2, it becomes 2. Net effect, what have you got? You've got the function to be less than or equal to 2. It's a huge thing. You've got the range. See, f of x is less than or equal to 2 means what? You have got the function to be something which is always less than or equal to 2. When we interpret it, the range therefore works out as everything starting from minus infinity to 2. You can have all the values from minus infinity to 2. That's how it comes. So that is your range. Since it was not we were not able to get it from there, we have used our algebra and we have found it out. That is your first subpart. Now we'll go to the second subpart. Second subpart also, the domain is given, x is belonging to R. You have to get the range. Now in the range, it's being told that f of x is x squared plus 2. Same thing. You can take some values first and let's see if that is helping us. And if it is not helping, then maybe we will resort to algebra. So see, f of 0 here. F of 0 is 2. Very clear, because 0 plus 2. If you take f of 1, it is 1 squared, which is 1. 1 plus 2, which is 3. Suppose if I take f of minus 2 for a change, then minus 2 squared is 4. 4 plus 2, it's 6. So you're getting f of minus 2 as 6. Now what is happening? Every now and then we've got functions. You've got values which we know they are positives. Yeah, it's clear to us that they are positives. But we don't know whether there is a upper limit, whether there is a lower limit. We're not very clear. So what we will do is, since things are not clear, let's go to algebra. So see, for any real number, it's very clear to us that because we are talking of, we have to reach x squared plus 2. For every real number, it's very clear to us that x squared has to be positive, and maximum it can be 0 also, because depending on the value that you're taking. So x squared is greater than 0. To reach to the function, you require x squared plus 2. So to this inequality, let's add 2 to both sides. So it is x squared plus 2 greater than or equal to 0 plus 2, which means that this is f of x is greater than or equal to 2. Again, it's a huge data. The range is any value after 2. That is what is the meaning. That you can have the range to be, I'll just check the function. What does it say? Yes, it is any value after 2. That is how your function works out. That's about this. Now, we have the third subpart where they give us a function f of x equal to x. It's an identity function, right? And domain is given to us, x is any real number. Now, they ask us to find the range. Now, you take a real number, you get the real number back. It's quite obvious, isn't it? See, suppose if you take 0, f of 0, 0 only, f of 1, 1 only, f of minus 1, minus 1 only, f of 10, 10 only. Okay, so you take any real number, you get the real number back. So range is almost predicted, right? So your range is real number itself, because the domain itself is real number. So range is the real number itself. Very, very interesting and very, very technical approach. Depending on your observation, if you are able to predict from the observation, we predict the range directly. If things are difficult, then we resort to algebra or whatever little knowledge of the maths that we have, and we come across the range. This is about this exercise. We finished exercise 2.3. In the next video, we will start with the miscellaneous. Thank you.